So let's do an inventory of all forces that we will use in grade 12 physics. All right. So the first one is gravitational force. Um, it's a non contact force, it's one of the fundamental forces, actually. We use the symbol Fg, and the gravitational force, its magnitude is proportional to the weight, so mass times gravity, and is always perpendicular to ground. All right. So that's what we need to know when we draw a free body diagram when we deal with this force. Later on, in a larger scale, we're going to see that the gravitational force is actually pointing toward the center of a object with mass m. The normal force, or also known as apparent weight, we use the symbol Fn, and normal force is pretty much a push away force between two surface contacts. So the main thing that we need to know is that is perpendicular to contact surface. So we need to have a contact surface, and we need to have some pushing against the two objects. Surface. All right. The force of tension, we use the symbol Ft. It's a force that acts along a rope. All right. So a rope, and it's the same throughout the rope from one end to the other. The ropes and pulleys in physics are massless, just so that we keep our problems simple and frictionless. All right. And keep in mind that the only job that pulleys have, the only purpose in life, is to change the direction of tension, not its magnitude. All right. Then we go to the frictional forces. The two that there are many types, but the two that we're going to deal with are static friction and kinetic friction. So we'll start with static. I use FF for friction, then I put an S and an index as to denote that that's a static friction. The static friction is parallel to contact surface. All right. And it opposes attempted motion. It opposes not an actual motion, but attempted. And actually, not just any motion, but sliding motion. That's the one we're going to deal with. All right. So again, it's parallel to contact surface, and it opposes attempted sliding motion. The kinetic friction does the same job, has the same direction, so it's parallel to contact surface, but instead of opposing an attempted motion, it opposes an actual sliding motion. All right. We have elastic force. We use the symbol, so now I have to start going like this. So we use this Fs. S means for it means spring force. It's pretty much parallel to the spring and opposes a stretch or compression. All right. Then we have air resistance, Fr or FAIR. It's opposite direction of instantaneous velocity. So whatever direction the velocity of an object is at a given instant, an object is moving through air. Air resistance will oppose that motion and will therefore will be in the opposite direction. Then we deal with these two in unit 4 or unit 3. Sorry, unit 4. So we'll leave it for then. However, one is Fe for electrostatic force, the other one is Fb for magnetic force, all right? Applied force is pretty much any of the above, all right? When we really don't care what is the actual source, we just call it applied force, all right? Then we have the net force, which is the vector sum of all forces acting on an object. All right. And whatever we learned about vector addition or subtraction, it applies here as well. Centripetal force is nothing but the net force on an object that is moving in a circular motion. So it's nothing new. We just call it centripetal to point to the fact that it points toward the center. Centrifugal force is not a force, it's actually a fictitious force. It's a fictitious force that we come up in non-inertial frame of reference. So a non-inertial frame of reference. All right. To explain what is it we see. Okay. So those are the forces that we're going to use to solve our problems and draw free body diagrams in dynamics of grade 12.